Hello everyone and welcome to Campus 101 exam series. My name is Dr. Piro. I'm so excited to be here with you, and today we're going to be looking at gaseous fuels. Now gaseous fuels they are cheap questions that come out regularly in your exam. So today we're going to be looking at gaseous fuel. So what is the meaning of gaseous fuel? Why do we have gaseous fuel in the first place? Turns out that most of us use what to cook at home. Okay, some of us use kerosene, some of us use firewood and coal and all those kind of things. And those things, for example, firewood produces smoke. It produces smoke that stains your pot and is even dangerous to your own health when you inhale it into your lungs and all that. So gaseous fuels provide an alternative to cooking that is economical, safe, and even very good. That's why all of us use gases now, like gas cylinder to cook in our house now. And before the advent of the gas cylinder you had in your house, gaseous fuels were used. Now again, they are used because I'm telling you the importance now and the relevance of gaseous fuels. They were used because one, they are cheap. They're relatively cheap to produce compared to kerosene and all those kind of these guys. They are cheap. One, they can get to very high temperatures when we use them. And don't forget, a fuel, we define a fuel as anything that can be burnt to produce energy. All right, so these gases can be burnt, they can be combusted to produce energy. High temperatures can be gotten from use of gaseous fuels. Another important example is that no smoke, no ash. So anytime you think of gaseous fuels, just remember no smoke, no ash. All right. So and then they can be used in homes, they can be used in industries. All right. They can be used to cook and then used to any other various uses that you can think of application of fuels. They are cheap, high temperature, no smoke, no ash, and we can regulate the amount of heat that we have. So we can control, the combustion. Exactly. So that's how we put it in chemistry. So gaseous fuels are an important source of energy. We burn them to produce energy. They are cheap, they give high temperature, no smoke, no ash, controlled combustion. They can be used in homes and every other places. All right, so what are the examples of gaseous fuels that we have? All right, so we want to take a quick look at these ones. These are the most important ones that come out in the exam, so pay very close attention. The first one I'm going to tell you about today is water gas. Now water gas is important in your exam. Now it's very cheap to know. This is how you just easily know water gas. Water gas, what is the component of water gas? What makes up water gas is just carbon monoxide and water. That is the component of water gas. So carbon monoxide and water gives us what? Water gas. How is water gas produced? Water gas is produced when we blow. Now when we heat carbon to your coal. When you heat carbon to a high temperature and it's white hot, and then you pass steam, all right, you pass steam across it, what you will get is what we call a combination of carbon monoxide and water. But in this case, it will be carbon monoxide and steam. So that is water gas, all right, and it's very, very easy for you to remember. Now, when you burn coke and steam, what will happen is the total combination of water gas will now be carbon monoxide and hydrogen. All right, this oxygen molecule in the water will now combine with the carbon, so that what makes up water gas at the end of the day is carbon monoxide plus hydrogen gas. I know all these are gases, all right, so that's why I call them gaseous fuel. So carbon monoxide and hydrogen eventually gives us what we call water gas. Cheap to remember. The next one we're going to be looking at quickly and briefly is natural gas. I've colored it green here. I know all of them seem similar, but don't worry, today we're going to get the difference in all of them separately. All right, so natural gas is made up of methane. All right, methane is the first member of the alkanes in your organic chemistry. I'm sure you remember organic chemistry. If you don't have a good knowledge of organic chemistry, we're going to do a video on homologous series. You can check that out so that you get your organic chemistry straightened out. All right, so natural gas is a combination of methane and ethane. All right, it is called natural gases because it is the first place it was discovered was among what they call marshes. Now marshes are just swamp. A swamp is where, for example, look at the rice farm where you have some plants there, and then you have water and mud and all those kind of hydrogen, water gas. Nitrogen, producer gas, because producers are plants and nitrogen is rich in plants. And water gas, hydrogen, because hydrogen is abundant in water. If you remember that, my dear, you have escaped a bombshell like that. Alright, so producer gas is made of majorly of carbon monoxide and nitrogen gas. Now, how is producer gas produced? That's funny. Producer gas being produced, all right? So it is produced by running air, hot air, and carbon. Air and what? And carbon. I'm going to write coke here as carbon because coke is when you heat carbon to a high degree and it's white hot, all right? Now, what is the most abundant component of air? Exactly. Air is made up of what? 70% of what? Nitrogen. And then 21% of oxygen, and then 2% of inert gases and other gases. But the point is, 70% of air is made up of what? Nitrogen. So by the time we add nitrogen to carbon, what we are going to get is a combination of carbon monoxide and nitrogen gas. And this is what we call producer gas. Of course, I know somebody is looking here. We have already looked at water gas. So chill. Now, the last we're going to be looking at is biogas. So what is biogas? Biogas is another combination of methane. Now look very closely. That's why I put them together. These ones have carbon monoxide and then these ones have methane in common, all right? But biogas is a combination of methane and carbon dioxide. Carbon dioxide. Biogas is a combination of what? Methane and carbon dioxide. As I said earlier, when we break down biological substances, all right, like refuse and all this, and then we anaerobically, that's the word. Biogas is gotten from anaerobically breaking down organic waste products. All right, so organic waste product. So in summary, today, what we have discovered is, I'm going to strike this out because we didn't use it. We have discovered that we have learned that gaseous fuels are gases, combination of gases that are bonds to produce energy. The reason why they are so important in chemistry and in real life is because we can use them in our houses to cook. We can use them in industries to produce energy. We can use them to warm our houses, especially during winter period. We can use them. Now, we also said that they are also important because they are cheap. They are economical. We can burn it to high temperatures. No smoke is produced, ash is not produced. We also said we can control or regulate, the temperature and the combustion. All right. And then we said the examples of gaseous fuels include water gas, natural gas, producer gas, and biogas. We said water gas is rich in what? Carbon monoxide and hydrogen. Producer gas, plants, producers, are rich in carbon monoxide and nitrogen. Now, natural gas, on the other side, is rich in methane and ethane, made up of 85% methane, while biogas is made up of what? Methane and carbon dioxide. Carbon dioxide. And that sums up our discussion today on natural gases. Don't forget, stay tuned for the other series in Chemistry 101. Cheers.